This is not easy integral, and I I try to use my method here, which is different from well, from many other videos on YouTube. So let me try this way. Okay, I want to find the antiderivative of e to the 2 cosine x. If I can find this antiderivative, I finish the definite integral easily. So this one, because the integrand function is exponential, so it must be exponential function multiply another function, say f of x. Right? If I can find f of x, I find the antiderivative of e to the 2 cosine x, then I can finish this integral. Now this one, if I differentiate both sides with respect to x, and the right hand side will be f prime of x times e to the 2 cosine x, and plus f of x times this derivative, what? Which is e to the 2 cosine x times negative 2 and sine x. Uh, this side derivative is equal to e to the 2 cosine x. Now then I cancel the common factor, so I have f prime of x minus 2 sine x f of x is equal to 1. Okay, good. Then I have this equation, f prime of x is equal to 1 plus 2 sine x f of x. Well, this is an important equation. I call this one a star. All right. Now, my objective is to find f of x. If we find f of x, we finish this one. To find f of x is not easy, but we have f prime of x here. And based on this function, I can observe to 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 conclude some kind of a factor that is f prime of 0 is equal to 1. Right? When x equal to 0, this is 0. It's equal to 1. Then f prime of a pi is also 0. Then I have a suggestion that f prime of x could be equal to a constant times x and pi minus x plus 1. When x equal to 0 is this equal to 1. When x equal to pi, this equal to 1. Well, that satisfies what I've seen here. So why pi minus x, not x minus pi? Because we discussed the function on the interval between 0 and pi. So that's the reason. And and then we can find that the f prime of x is equal to k pi x minus kx squared plus 1. Right? So we can have a f of x by integrating this one. This is a 2k pi x squared minus 3k pi q plus x plus c. So this is my f of x. Now, if we find f of x, we finish this integral. How to find f of x? We need a finding k and c. You have two constants to determine. Now, to determine two unknowns, you need two equations. So we must create two equations. And okay, we can create them by letting x be something, right? How about x is equal to pi over 6? Why? Because it's easy to calculate for sine. So f prime of pi over 6, we use this formula, right? This is equal to k pi over 6 minus k pi over 6 squared plus 1. Okay, so this one is equal to approximately 1.3708 k plus 1. It's nothing, just tedious calculations. I did my homework here. Now, and we can find f of pi over 6. Simply plug them into this equation, right? This is equal to 2k pi over 6 square minus k over 3 pi over 6 q plus pi over 6 plus c, which is equal to 0.3828k plus 0.5236 plus c. It's nothing but calculations, tedious calculations. So then we plug this one and that one into our star equation. So we can, this equation becomes 1.3708 k plus 1 is equal to 1 plus 2 pi over 6 for sine is 1/2, right? Time whatever is this f of x is plus 0.526 plus c. So after simplifying, we get c is equal to 0.9880 k minus 0.526. I call this equation 1. Okay, good. Now, then we need to find the second equation by let x equal to, say, pi over 4. So we can find f of prime of pi over 4. Simply we plug this into this equation, right? This equation. this equation. Sorry, this or that. Same thing. So this one equal to k pi times pi over 4 minus k pi over 4 squared plus 1. After tedious calculations, this is 1.8506 k plus 1. Then also we plug quarter pi into f of x, into this one. So this one is equal to k over 2 pi, pi over 4 square, this one, minus k over 3 pi over 4 cubed, yeah, and plus k over 4 pi over 4 plus c. After calculations, tedious, this is 0.8075 k plus quarter pi plus c. It's nothing but calculations. And then we plug these two into our star equation. So the star equation becomes 1.8506 k plus 1 is equal to 1 plus 2. Sine quarter pi is 1 over root 2, right? Times f of a quarter pi, 0.8075 k plus quarter pi plus c. Then we get a new equation after simplifying. C is equal to this and minus 0.7854. I call this equation 2. See, we have equation 1, we have equation 2. Then these two equations, equation 1 and equation 2, will give us the values of a k and a c. K is equal to negative 0.5377. C is equal to negative 1.0548. Yeah. Then we plug this into the f of x, so we can find f of x. Well, this is equal to, well, this is equal to 2 times negative 0.5377. Yeah, I use this one's. I use this one's better. Yeah, x squared times pi, right? Times pi x squared minus 3 negative 0.5377 x cubed plus x plus c. Plus c is 1.05. Well, after simplifying, f of x is equal to negative 0.8446 x squared plus 0.1792 x cubed plus x minus 1.0548. Well, this just tedious calculations. Now then, I finally I can calculate the target integral, which is e to the 2 cosine x dx. This is our objective in the first place. Now this one is equal to f of x times e to the 2 cosine x from 0 to pi, right? Now then, is f of a pi e to the 2 cosine pi minus f of a 0 e to the 2 cosine 0. Well, cosine pi is a negative one, right? So this is equal to negative 2, which is the bottom. Now here, replaced by pi, right, to 0.84469 pi square plus 0.1792 pi cube plus pi minus 1.0548. Yeah, that takes care of this one. F of 0 is just, these are zeros, and this is just negative become positive, 1.0548 times cosine 0 is 1, so times e squared. So after the calculations, this is equal to 7.6995. That is the very result for this integral. Now I check from the internet. From internet, this integral is 7.1615. See, my answer is this. I think there is what? There's a difference between them, right? Why? Because my construction of f of prime of x is based on my observation of this. This is approximation. See, this description, this equation describing f of prime may not be exact, may not be truly f of prime of x, but very close. Should be close. So whole process is approximation. So this is my method, which is approximation. I didn't go through with a sophisticated method of integrations. I just use a very elementary method of integrations. So I don't know. This is a method. Uh, I hope you have your comment, and I would like to see to know your comment on this method. Thank you.